Interconnectivity. In this module, we'll learn about VNet peering, VNet to VNet connections, the express route connections, and along with the theoretical understanding, we'll also understand how you can practically implement the network connectivities. I suggest that you create your own Azure account and then do as much labs as possible. Let's get started. If you have multiple virtual networks, then they will be isolated from each other by default. There are two ways to connect to them. Number one, using a VNet peering, and the second one is using a virtual network gateway. A virtual network peering is by far the easiest method, so we'll start with that. A VNet peering is simplest and quickest way to establish a connection between your VNets. Virtual network peering enables you to seamlessly connect two Azure virtual networks. Once the peering is complete, the virtual networks will appear as one for connectivity purposes. Now there are two types of VNet peering. One is regional VNet peering, and the second one is global VNet peering. So if you have Azure VNets in the same region and you have completed a VNet peering between the two, then it is regional VNet peering. Global VNet peering, on the other hand, connects Azure virtual networks in different regions. So let's say one of them is in East US and another one is in Southeast Asia. Then you are running a global VNet peering. When creating a global peering, the peered virtual networks can exist in any Azure public cloud region or China cloud regions, but not in government cloud regions. You can only peer virtual networks in the same region in Azure Government Region Clouds. In the next video, let's talk about the benefits of using local or global virtual network peering. Let's talk about the benefits of using local or global virtual network peering. The network traffic between the peered virtual networks remains private. That means that the traffic between the virtual networks is kept on the Microsoft backbone network. There is no public internet, there is no public gateway, neither an encryption is required in communication between the virtual network. A low latency, high bandwidth connection between the resources in different virtual networks is always maintained. That ensures highest performance. Once the virtual network is peered, the resources in one virtual network will be able to communicate with resources in a different virtual network. With VNet peering, you will be able to transfer data across Azure subscriptions, different deployment models, and also across Azure regions. On top of it, most of the businesses look for no downtime. So there is no disruption to your businesses because there is no downtime to resources in either virtual network when creating the peering or after the peering is created. The default VNet peering configuration provides full connectivity. US geographical region. It doesn't matter though, they can be in two different regions as well, so their location really doesn't matter in this case. You can have VNet peering between the VNets in different regions as well. To create a VNet peering, I'll click on one of the VNets and then scroll down to the point where I see peerings. Click on that and then on the top you will see the add button. Now you will get a blade or a form where you gotta fill up these values, and depending on your requirements you may want to pick and choose one or more of them. Let's go through these options one by one. The first box is how do you want to name the peering. Based on your naming conventions and standards, you may want to name the peering. I'll just call it as peer 1. Usually we always select resource manager here because the classic methods of deployments will be deprecated soon. So I'll select resource manager here. If you know your resource ID, you can select that. But if you do not know your resource ID, which in this case I don't know the resource ID, so I will uncheck it. I will tell you where you can get this resource ID from. Usually it's in the properties box and I'll tell you where it is. My subscription is pay as you go. The virtual network to which I want to peer is new underscore VNet1, right? That's the only VNet I have. I'll select that, and then you can select the name of the peering from VNet1 to VNet2. This name is from VNet2 to 1, whereas this one that will be created will be from 1 to 2. So I'll call it as peer 2. Now if you scroll down, there are furthermore options which controls the behavior of traffic to and from the VNet. The first one is allowing virtual network access from VNet2 to VNet1. The second one is allowing VNet access from VNet1 to 2, right? Do you want a single direction or a unidirectional communication or a bidirectional communication? As you see, both of them are enabled at this time. That means by default you have bidirectional communication between VNets when you enable VNet peering. But if you want just unidirectional communication, let's say from VNet2 to VNet1 only, and no communication between 1 and 2 must exist, or from 1 to 2 must exist, then you will set it to disabled. I will choose enable for this and move on to the next setting. Configure forwarded traffic settings. Allow forwarded traffic from VNet1 to VNet2. Do you want the traffic to be allowed from VNet1 to 2 or not? Which is the forwarded traffic. So if the traffic comes to VNet1, do you want that traffic to go to VNet2? Well, yeah, anything that's residing inside VNet1 will get routed to VNet2 anyways. But what if there is certain level of forwarded traffic that comes from the external environment to VNet1? Should that get forwarded as well to VNet2? Is controlled by this setting. Now looks like that is disabled by default, and the next option, which is allow forwarded traffic from VNet2 to 1, is also disabled by default. So you can have these settings enabled if you like. If I enable this too, that means that I will have all the forwarded traffic going to and from 1 to 2. The next option is gateway transit. When you hear the term gateway in networking terminologies, it just means an external endpoint. In this case, it will be a virtual network gateway. Do you want those gateway transit to happen? So if you allow the gateway transit, then the resources in this VNet 1 and 2 will be able to talk to the resources outside the virtual networks. Probably there is a virtual network gateway communication between on-premise and your VNets. Then this checkbox means that your virtual resources in your VNet will be able to communicate with the resources in your premise. I'm getting that error message because none of my virtual networks have a virtual network gateway. In the next set of videos, you will see how a virtual network gateway is created, and we'll do the lab for that. But at this time, I will uncheck this box and proceed to creation of the virtual network peering. Looks like the peer is created and connected on VNet 2 side. I will go and check it on the VNet 1 side as well. So I'll click on new underscore VNet 2, go to the peering section to see if the peer 2 is created. Looks like it is. That means I have a bidirectional peering created between the two virtual networks in East-US. Now this is how simple it is to create a VNet peering between the virtual networks. For example, the subnet gateway can then let you communicate with a site-to-site VPN so that you can connect to on-premise network. That means in this case, VNet 2 can talk to on-premise infrastructure as well, because you have a site-to-site VPN connection from VNet 1 to the on-premise infrastructure. The same thing can happen from VNet 1 to other VNets, or a point-to-site connection which VNet 1 may have. In this case, the VNet 2 can talk to all those networks because VNet 1 has allow gateway transit enabled. So in these scenarios, gateway transit will allow peered virtual networks to share the gateway and get access to the resources. So all the traffic would then flow through the virtual network gateway. And that means that you do not have to deploy a virtual private network gateway in the peer virtual network. You got to deploy it just once, and it can then be used to have communications forwarded to other networks. Theory of transitivity states that if A trusts B and if B trusts C, then C will trust A. That's what transitivity means. Now, VNet peering is non-transitive. That means that if you establish VNet peering between VNet 1 and VNet 2, and then you also establish another peering between VNet 2 and 3, then VNet peering capabilities do not apply between VNet 1 and VNet 3. However, you can leverage other mechanisms like user-defined routes and service chaining to implement custom routing that will provide transitivity. So if you would like to implement a hub and spoke architecture or overcome the limit on the number of VNet peerings per virtual network, then service chaining is the way to go. You can deploy hub and spoke networks where the hub virtual network can host infrastructure components such as network appliance gateways or VPN gateways. All the spoke virtual networks can then peer with the hub virtual network. Traffic can flow through network virtual appliances or VPN gateways in the hub virtual network. You can connect your VNets with a VNet to VNet VPN connection. Using this connection, you create a VPN gateway in each virtual network. You can also call it as a site-to-site connection. A secure tunnel using IPsec IKE is established, and that then provides the communication between the networks. You can also establish a similar connection between on-premise infrastructure and the Azure VNet. So with a VNet to VNet connection, your VNets can be in same or different regions. They can be in same or different subscriptions as well, or they can be using different deployment models. And if you would like to have connection between on-premise infrastructure with Azure, you can do so with site-to-site connections. This site-to-site connection is possible with a virtual network gateway. So you need to have the gateway attached to the VNet, and that gateway will then route the traffic to and from your virtual networks. Let's get started with the creation of virtual network gateways. The first step is to select the network in which you want to create the gateway. So I'll select VNet 1 here and then click on subnets. Once you click on subnets, you will see a special entity called gateway subnet. If you want to create a gateway subnet, we must be creating a subnet specifically for the gateway. If you want to create a virtual network gateway, we must be creating a gateway subnet specifically for that appliance, which is the virtual network gateway. So our device, the virtual network gateway, will reside in this special subnet. It doesn't have to be big. You can keep it small as /28. That's fine. That will be 10.20.40.0/28. So I'm getting about 11 IP addresses with 5 Azure reserved addresses. That's fine. Now I'll just click on OK. Our gateway subnet is created. Now it's time to create our virtual network gateway. So I'll click on the search box and type virtual network gateways here. You can either click on the plus add button or create virtual network gateway, and then it will show you certain options where you gotta fill up to create the gateway. Now the name of the gateway, please follow your naming standards. I'll just type it as gateway, which should be located in the same region where your VNet is. Your VNet and your gateway cannot be in two different regions. They must be in the same region. Now, Do you want to create a VPN or an express route? VPN is for site-to-site connections. Express route will give you much more bandwidth than what VPN can provide. We still have to talk about express route, and we'll be doing that in the subsequent videos in this module. What is a VPN type? The VPN types can be either route-based or policy-based. Azure Network Gateways support both route-based and policy-based. What does that mean? Policy-based means that there will be static routing, and route-based means it will be supporting dynamic routing VPN. So if you have new subnets created, and if you want those subnets to be addressed and to be discoverable by the VNet, then we must be using route-based VPN. New subnets will not be discovered if we select policy-based VPN. And hence, policy-based VPN is static, and route-based routing, as the name says, it is dynamic in nature. That means it will detect new subnets and route the traffic to them dynamically. I will leave it as route-based for now. SKU. When you create a virtual network gateway, you specify the gateway SKU that you want to use. You will select the SKU that satisfies your requirements based on the types of workloads, throughputs, features, and SLAs. So if I click on this drop-down menu, you will have the various options here to select the kind of SKU you want. You have the options to choose right from basic all the way up to VPN GW5AZ. What does basic mean? Basic means that you can have maximum up to 10 site-to-site tunnels. What's more important is the speed. You get up to 100 Mbps with a basic connection. But for mission critical workloads and for high throughput needed applications, 100 Mbps may not be enough. So you may want to go for something higher. The VPN G1 will give you up to 650 Mbps. So as you scroll down from top to bottom, from basic to VPN GW5AZ, you may range your bandwidth from 100 Mbps to 10 Gbps. And 10 Gbps will be the generation 5 type of SKU, which will then give you 10 Gbps bandwidth. You can see how much bandwidth is required, communicate with your network guys and the application owners to see how much bandwidth is required, and you can pick and choose one of them. Keep in mind that the resizing of the gateway SKUs is allowed within the same generation, except the resizing of basic SKU. The basic SKU is a legacy SKU and has feature limitations. In order to move from basic to any other VPN gateway SKU, you must delete the basic SKU VPN gateway and create a new gateway with the desired generation and SKU size combinations. Depending on the kind of SKU you have chosen, your billings will then be directly proportional to it. In this case, since it is a lab, I'll just select the basic version and then select generation. You got just one generation here, but then if I toggle to others, I may have others too, right? The last one here is GW5AZ, which is generation 2. So there are two generations of virtual network gateways. One is generation 1 and other is generation 2. You can toggle between them. Moving on, I'll switch back to basic and leave it as generation 1. The virtual network in which I want to host it is VNet 1 because that is where my subnet gateway is created. Then the subnet gateway address range is automatically picked up. Do I want to create a public IP address? Well, yes. And then I can just give it some name. Say new IP for gateway. Enable active mode. To achieve high availability for cross-platform and VNet to VNet connectivity, you should deploy multiple VPN gateways. You also need to establish multiple parallel connections between your networks and Azure, and this will ensure high availability. So if you have to establish such redundant communication channels, then you will go for an active mode. And because it also needs a secondary communication channel, I will need a secondary public IP address too. In this case, I will leave it as disabled. The next option is configuring BGP, Border Gateway Protocol, ASN. Now, BGP, ASN stands for Autonomous System Numbers. And that's how your devices are uniquely identified on the network. So with a single technical administration, you will be able to identify your device's registered number, which will then be your ASN. So you can assign an ASN to your device, and the device is virtual network gateway here. By putting a valid number here, you're saying that you are assigning this number to your network gateway. In this case, I will leave it as disabled and then click on next. I'll not assign any tags at this point. Let's click on review and then finally click on create. Now this resource deployment really takes some time. I've noticed that the whole fully functional virtual network gateway is deployed in about 45 minutes. So I'll pause the video for now, and if there are any changes on the screen, I will resume it and then explain them. But it may take about 45 minutes. Just in case if you are doing the labs, please keep in mind that you do not refresh the page, leave it as it is. If you want to do some activities, open a new tab and then run your operations, but do not disturb this deployment. Virtual network gateway is created. Now, there are certain configurations that we need to do for it to work. The objective is to have a point-to-site connection created between the laptop which I have and the VNet. In the VNet, we have the virtual network gateway there, which will then be acting as a VPN device. So we are creating a point-to-site connection. To create a point-to-site connection, I will first go and click on this point-and-site configuration. What we must type here is the address pool, which must not be more than /24 CIDR block range. So I'll choose 192 series here to keep it simple and call it as 192.168.30.0/24. Now the next thing it's asking for is the root certificates. Yes, we will need certificates to encrypt the traffic. So there are several ways you can get a certificate. You can get a certificate from external provider like OpenSSL, let'sencrypt.com. There are several companies and organizations that provide certificates, and we need to purchase from there. But because it's a lab environment, I will use a self-signed certificate. There are several ways of creating a self-signed certificate. You can create a self-signed certificate with makecert.exe or PowerShell or OpenSSL.exe. There are several ways. Now I will use makecert.exe to create a self-signed certificate. But if you are PowerShell savvy, you can go ahead and do that. We can demonstrate that here, but just for the sake of simplicity, we'll use makecert.exe. I'll just launch command prompt, and in my C drive, I have already created a folder called cert. There I have a file called makecert.exe. Now I will use this file to create the certificate. So there's a command that I have in my notepad here that I need to type in to create a certificate with the name Azure VPN root cert. So the name of the certificate is this. The length of the certificate is 2048 encrypted with SHA-1 algorithm. Eventually, the certificate will be named as Azure VPN root cert. Now this is what we gotta take it to Azure for encrypting the traffic. Now I'll just paste it on the command prompt to make sure that the certificate is created in my C cert folder. There you go. Hit enter, give it a minute, and then navigate to the folder and you will see a new file called Azure VPN root cert, right? You'll also find that in your certmgr.msc, which is certificate management store for user stores. Expand the personal store, and then under certificates, there is a certificate called Azure VPN root cert. There's a client cert as well. I just delete it because we don't need it for now. And what we have to do is export it. Yeah, click next. No, do not export the private key. And then select base 64 encoded. This is because if I select DER encoded binary, then the certificate will all be gibberish. We will not be able to read it. But with base 64 encoded, I'll be able to read it in a text format. So I'll click on next and then browse it to the same folder. Just to organize it, I'll keep it under the same folder called C cert and call it as root cert. Save it and let us proceed with the wizard. Finish it. Now if I go to the same path, I have this file called as rootcert.cer. What I gotta do is open this file with Notepad or Notepad++ better, and then the content of this will then be copied to Azure. I'll show that to you. Now I'll open Notepad++, Notepad++, there you go, and then click on File, Open, navigate to the path which is in my C drive. There you go, and the file name is rootcert.cer. Click on Open, and yeah, it's all is good. So make sure that you do not copy the whole thing. Do not do Control A, and that's because we just have to copy everything except the first line and the last line. Once you've copied this, go to your Azure portal and just paste it here in the public certificate data section. Name, this can be anything, just type cert data there, that's fine, and then click on save. If everything is alright, you'll not get any error messages, but if there are any problems with the certificate data, then you may encounter problems and the errors will then pop up. Mostly you get these errors when you're using not certified, not compatible text editor. Notepad++ is a compatible text editor, so there's no problem here. But click on save one more time because you might have noticed there's some error there. Hopefully it takes it in. Okay, looks like it has saved the settings successfully. Now what we have to do is download the VPN client, install it on your local device, and then you will be able to connect to it using the VPN client. But before doing so, you must have a client certificate as well. To create a client certificate, you need to use the second command. So I'm using the first certificate here, and from this I'm creating a client certificate. This one is a root certificate, and now what we are creating is a client certificate. Using the same algorithm and length, I'll copy this, open the command prompt, and just paste it here. Okay, looks like we haven't copied it properly, so we'll go back, and this time paste it. Hit enter. That's it. Now if you go to your cert store, you must have the two certificates here. One is a root certificate, another is a client certificate. Good. Now go back to the Azure portal and then click on this download VPN client. Okay, so the VPN client is downloaded now, so I will extract this into another folder so that we can take a look at it. What you will see is that there are different executables for x86 version, and there's one for 64-bit version. Now since I'm using a 64-bit version, I'll double click on it and then let that get installed on my machine. Sometimes your antivirus may block this installation because it's an executable. It's not signed by Microsoft, so it may just stop the execution and you may get some random error messages like this, right? Windows cannot access the file. So I'm using Norton on my machine and it has automatically looked at the executable and it thinks it's not right file. So I'll just ignore this message. Looks like it has also deleted the file from my computer. So I'll go to view details and see if my antivirus has options to restore the file and also whitelist this particular file. Yeah, so I'll just click on restore here and then yes, exclude this from future scans. Absolutely. So if you got different antivirus, let's say McAfee or Kaspersky or something, look at the options to how you can whitelist this path and whitelist the executable. It's okay, it's not malicious. Just double click on it. This time the installation must just go through. Click on yes. There you go. You may see a few flashes of the command prompt like that, and that's done. Now how do you verify whether the client exists or not? Well, you just go to the network connection properties. Yeah. Now I usually use a shortcut called ncpa.cpl control panel shortcut. Go there and then you will see a specific icon for Microsoft Azure VNet 1, something like this, right? This is different. Now double click on that and then click on this little icon and look at the options as to how you can connect it. Done. There you go. Click on connect. All right. Looks like we are connected now. Very good. So now I have a private tunnel from my laptop to the virtual network in Azure. I've already created a virtual machine in Azure. So what you will see is a virtual machine that is created in my virtual network 1, and it has a private address 10.20.30.5. I would of course be able to connect with the public IP address, no problem. But the idea is to route the traffic privately through the VPN. So I'll copy this, and just for testing purposes, I'll see if I can telnet to the virtual machine using a private IP and not a public IP. 3389 is the port number for RDP. There you go. Now you see 10.20.30.5 is connected. Absolutely not a problem. Now I will try to do an RDP to the machine using a private IP. My antivirus is working. It has removed certain executables. That's fine. But you see this, I've got a prompt. That means that the connectivity is established. Now I really do not have to type in the credentials to prove something, because what we had to prove was a private connection, a network connection to be established between my laptop to the virtual machine in Azure using a private IP, which is working perfectly fine. So with this lab demonstration, we have been able to successfully configure a point-to-site connectivity between your personal device and the one in Azure. Similarly, you can set up a site-to-site connection and an express route as well. In the upcoming video, we'll learn about different configurations of express route, the capabilities, different kinds of connections you can have in express route, and how you can have a coexistence of site-to-site and express route together in your infrastructure. Express route. Azure Express Route lets you extend your on-premise networks into the Microsoft Cloud over a dedicated private connection. Now, this is facilitated by your connectivity provider. With Express Route, you can establish connections to Microsoft Cloud services such as Microsoft Azure, Office 365, and CRM Online. You can use Azure Express Route to create private connections between Azure data centers and infrastructure on your premise. Express Route connections do not go over the public internet, and they offer more reliability, faster speeds, and lower latencies. In certain connections, using Express Route connections to transfer data between on-premise systems and Azure can give you significant cost benefits. With Express Route, establish connections to Azure at Express Route location, such as your Exchange provider facility, or directly connect to Azure from your existing WAN network. ExpressRoute gives you a fast and reliable connection to Azure with bandwidths up to 100 Gbps, which makes it excellent for scenarios like periodic data migration, replication for business continuity, disaster recovery, and other high availability strategies. It can be cost-effective option for transferring large amounts of data, such as data sets for high-performance computing applications, or moving large virtual machines between your dev or test environments in an Azure Virtual Private Cloud and your on-premise production environments. You will use ExpressRoute to both connect and add compute and storage capacity to your existing data centers. You will get high throughput, and with high throughput and fast latencies, Azure will feel like a natural extension to or between your data centers. So you can enjoy the scale and economics of the public cloud without having to compromise on network performance. ExpressRoute provides you predictable, reliable, and high throughput connections, so you can build applications that span on-premise infrastructure and Azure without compromising privacy or performance. For example, you can run a corporate intranet application in Azure that authenticates your customers with an on-premise Active Directory service and serve all your corporate customers without traffic ever routing through the public internet. In the next video, let's take a look at the ExpressRoute capabilities. ExpressRoute is supported across all Azure regions and locations. The map here provides a list of Azure regions and ExpressRoute locations. ExpressRoute locations refer to those where Microsoft peers with service providers exist. You will have access to Azure services across all regions within a geopolitical region if you are connected to at least one ExpressRoute location within the geopolitical region. Let's take a look at benefits of using ExpressRoute. Microsoft uses BGP, which is Border Gateway Protocol, that is an industry standard dynamic routing protocol. BGP is used to exchange routes between your on-premise network, your instances in Azure, and Microsoft public addresses. We establish multiple BGP sessions within your network for different traffic profiles. Each ExpressRoute circuit consists of two connections to two Microsoft Enterprise Edge routers. Microsoft requires dual BGP connection from the connectivity provider. ExpressRoute connections enable access to the services like Microsoft Azure services, Microsoft Office 365 services, and Dynamics 365. Office 365 was created to be accessed securely and reliably via Internet. So ExpressRoute requires Microsoft authorization. You get connectivity to all regions within a geopolitical region. That means that you can connect to Microsoft in one of our peering locations and access regions within the geopolitical region. For example, if you connect to Microsoft in Amsterdam through ExpressRoute, you will have access to all Microsoft cloud services hosted in Northern and Western Europe. You can enable ExpressRoute Premium add-on feature to extend connectivity across geopolitical boundaries. For example, if you connect to Microsoft in Amsterdam through ExpressRoute, you will have access to Microsoft cloud services hosted in all regions across the world. You can enable ExpressRoute Global Reach to exchange data across your on-premise sites by connecting your ExpressRoute circuits. For example, if you have a private data center in California, which is connected to ExpressRoute in Silicon Valley, and another private data center in Texas connected to ExpressRoute in Dallas, with ExpressRoute Global Reach, you can connect your private data centers together through two ExpressRoute circuits. Your cross data center traffic will traverse through Microsoft network. What are the bandwidth options we have? Well, you can purchase ExpressRoute circuits for a wide range of bandwidths from 50 Mbps to 10 Gbps. Make sure that you check with your connectivity provider to determine the bandwidths that they support. On top of it, you have flexible billing models. So you can pick a billing model that works best for you. You can choose between unlimited data, metered data, and ExpressRoute Premium add-on. What is unlimited data? So with unlimited data, billing is based on a monthly fee. All inbound and outbound data transfer is included free of charge. With metered data, billing is based on a monthly fee and all inbound data transfer is free of charge. Outbound data transfer is charged per GB of data transfer. Data transfer rates vary by region. With ExpressRoute Premium add-on, this add-on includes increased routing table limits, increased number of VNets, global connectivity, and connections to Office 365 and Dynamic 365. There are certain FAQs of ExpressRoute that are presented in this document.microsoft.com, and it is recommended to go through these certain facts when in doubt. Let's go through ExpressRoute connections in the next video. ExpressRoute is a direct private connection from your WAN to Microsoft services, including Azure. Site-to-site VPN traffic travels encrypted over the public internet. Being able to configure site-to-site VPN and ExpressRoute connections for the same virtual network has several advantages. You can configure a site-to-site VPN as a secure failover path for ExpressRoute, or use site-to-site VPNs to connect to sites that are not part of your network but probably are connected through ExpressRoute. Notice that this configuration requires two virtual network gateways for the same virtual network. one using the gateway type VPN and other using the gateway type express route. At this moment, the deployment options for site-to-site and express route coexisting connections are only possible through PowerShell and not the Azure portal. Cloud migration is a long-term process and not an immediate one. The bigger the will take, and it can take years. To confuse matters, some assets may never be migrated for security or other reasons, so a complete migration will never happen. Thus, hybrid solutions are required. Services will be migrated from on-premise to the cloud over time, and so they need to be integrated seamlessly with on-premise services. Confidentiality is an important requirement for a service used to connect to on-premise data centers with a virtual network of resources in Azure. Most of the time, the connection goes through public internet where it is susceptible to attack. VPN, or virtual private networking, allows reserved connections between nodes throughout the public internet. And that ensures communication is kept secret with encryption, ensuring the communication parties are who they say they are and preventing man-in-the-middle attacks. VPNs are scalable solutions which can accomplish several goals. It is possible to connect to a cloud VPN from a single computer, to connect an on-premise network to a VPN, or to connect multiple virtual networks to each other. Point-to-site VPN technology is the easiest way to connect to remote virtual network through a public internet, and we demonstrated this in the lab in one of the previous sessions. To do this, all you have to do is install a software on the client PC that will connect with the VPN. So that software, in this case the VPN client, guarantees a secure, encrypted connection to the cloud resources as if they were on the same physical network as the PC. Point-to-site VPN technology is a practical solution only when few users need to connect to the VPN. Typical scenarios would be remote administration or troubleshooting. Also, it's a good solution during development for remote workers or debugging sessions. It is not the best solution when the number of connections start increasing or when an entire network needs to reach the remote network. A remote point-to-point VPN gateway has limitations except more than a specific number of connections and can be difficult to manage as every connection has to be defined independently. That's when a site-to-site VPN comes in, and this is a single private connection from an on-premise network to the remote virtual network over the public internet. This projects an entire on-premise LAN to the remote Azure virtual network. The single connection is shared among all the on-premise nodes across the remote endpoints. You would need a hardware appliance that can be used to build up a site-to-site VPN. And keep in mind that not all networking appliances like consumer routers would support site-to-site VPNs, so a network upgrade may be required. There is also a possibility of using software appliances installed on a server inside the LAN. For example, Windows Server has a routing service to connect the LAN to the VPN. Now, there can be issues with respect to quality and reliability of the public internet connection. In general, it is not possible to guarantee internet performance, especially if corporate demand increases. There are too many issues not under the company's control. So instead, you will use ExpressRoute. ExpressRoute is a private connection for an on-premise data center to Azure data center. It is a dedicated connection co-located in a third-party connection providers all around the world. Traffic does not travel in the public internet, but it is kept private to ensure reliability, faster speeds, lower latencies, and security. SLA is guaranteed by redundant connections to Microsoft Edge network. Different performance levels can guarantee from 50 Mbps to 10 Gbps throughout the network service provider or exchange provider. The key factor here is that the connection is not public and can reach high level of security and reliability. Performances are ensured by layer 2 or layer 3 Ethernet connections between on-premise network node and the Microsoft cloud endpoints. Connectivity can be in any form. ExpressRoute is ideal for data storage access, backup, and disaster recovery. It is also preferred to connect to Office 365 or dynamic CRM services solutions. It is not a service useful or cost-effective for everyone. It can become convenient when you have frequent big data transfers on daily basis. As ExpressRoute is the most expensive solution for providing connections between on-premise data center and Azure, it should be analyzed well and tested. If site-to-site VPN connection is enough for the company, then you probably may just settle down with site-to-site VPN. There is a possibility of needing to create multiple virtual networks for security or for performance reasons. In any case, two virtual networks, even in the same data center, should be considered as two virtual networks that need to establish reliable communications through the public internet. In that case, we require that the two VPN gateways allow intra-region traffic among owned virtual networks. That is a scenario for VNet to VNet VPN solutions. This ensures multi-region availability of cloud infrastructure, and there are many different scenarios for this, such as SQL Server always on high availability, or this can be useful for distributing geographically distributed partitions in NoSQL solutions deployed on virtual machines connected to different virtual networks. If you need to access virtual networks from multiple on-premise sites, such as when a company has multiple geographically distributed physical locations, then you need to share a connection to the same Azure virtual network. This network configuration is commonly known as hub and spoke topology. With this, we conclude this video, and then we understood when to use a point-to-site, a site-to-site, and an express route. Networking is one of the core components, and that makes understanding virtual networks worthwhile. So the next question is, what next? In order to master something, it's important to get your hands dirty. If you didn't follow along with the demos, I recommend trying it out yourself. You don't need to build out the same thing that I did. However, build something. Start with something simple and begin increasing the complexity. I hope you found the module useful. I would always love to hear the feedback from you. It doesn't matter if it has to be positive or negative feedback, because hearing from you helps to shape future content. You can reach out to me in different ways. I'm on LinkedIn and on different community forums. I hope to hear from you. Let me know what you like about the course and what you don't like. What sort of content would you like to see in future? Thank you, and thanks for watching.